Hi guys, it's Gurj, the maths tutor here online with Sherpa. This is the first Facebook Live of many that they have planned with loads of different subjects. In particular, maths and English will be doing these. So today, the aim of today is to look at some problems that you'd see in both papers, both higher and foundation, and it's a real importance for the foundation students to get these right if they want to get those grade 5s, but equally they're meant to be sort of the bread and butter marks for the higher students. So for any student doing GCSE Maths on whatever exam board, these are really going to be some key problems that you want to get under your belt. So let's get going. With each of these problems, I'll zoom in and make sure they're visible to you. And try and share with you, because my background is a maths teacher but also an Edexcel Examiner, share with you where those marks are coming from. So what we've got here, the first problem, is 6.34 times 5.2. So we're times in decimals. It's never nice to times decimals. The way I often teach this to students is to say treat them as whole numbers and multiply them using a grid method that you're probably used to and you've probably been using since primary school. So if you use this grid method, we can do 4 times 2, which is 8, 3 times 2 is 6, 6 times 2 is 12. Going on to the second row, we'd introduce a 0 because we're dealing with the tenths column. 4 times 5 is 20. 3 times 5 is 15, and we can add the 2 to get 17. 6 times 5 is 30, add the 1 to get 31. Adding these two rows up, we can then get 8, 6, 2 add 7 is 9, 1 add 1 is 2, and we've got 3 on the end. Now, you might be thinking, well, 6.34 times 5.2 is definitely not 32,968. So the key here is to know, where do you put that decimal point? Well, if you look at the question, in the question there's 1, 2, 3 digits after the decimal. So if there's 3 digits after the decimal in the question, there must also be 3 digits after the decimal in the answer. So your decimal place would go between the 2 and the 9 to give you an answer of 32.98. 968, sorry. 32.968. I also do encourage students to make sure their answer makes sense. If you were to just round these numbers up, 6.34 is roughly 6, 5.2 is roughly 5, so 6 times 5 you know is 30. So the answer you're looking for should be around 30 anyway. So, you know, just a nice way of checking. It's a nice 3 marks, and it's often quite early on in the higher paper. Where do those 3 marks come from? Well, your first mark would come from getting one of these two calculations correct. So either 1268 or 31700. So 1 mark would come there. The next mark would be for getting the addition of those two correct. And the last mark would obviously be getting the decimal place in the right position, so getting the actual answer as accurate as it should be, so 32.968. Going on to the next problem, it's a 2 marker and it's algebra. Just in case you're wondering what the number here at the start of the problems mean, let's have a look. The 22, the first number, is what question number it would be on a foundation paper, and the 2 is what question number it would be on a higher. So like I said, at the end of a foundation, but at the start of a higher, and you'll see that throughout all of the questions we do. So expand and simplify. The 2 marks here, 1 would come from the expanding, and 2, the second mark, would come from a correct simplification. Several ways of doing this. I often go for what I call the monobrow, makes usually the students laugh a little bit, and the smiley face method. So each of these curly arrows that I've drawn represents multiplication. So we can do m times m, which is m squared. 7 times 3, which is 21. 7 times m, which is 7m. And m times 3, which is 3m. So getting that right would be your first mark for the expanding. The second mark would come from the simplifying, which if we simplify this correctly, when you simplify, remember to collect like terms. The like terms here would be 7m and 3m. So they're the terms we'd put together. So we've got m squared plus 7m add 3m is 10m. Add 21, which you can pop on the end. So the second mark would come from getting that written correctly with the correct signs, as you can see on screen. We will try and do a mixture today, so you're going to see a range of different topics, not just the same thing over and over again. The next question here is to do with angles, something from geometry. You can see there at the bottom it says it's worth 3 marks. So sometimes in these questions you're asked to give reasons. This one you're not asked to give reasons, but you are asked to show full working out. So what I encourage students to do is to definitely annotate the diagram as they figure things out, but also make sure their working out is very clear, structured, and methodical. So if we just read the question first and highlight some of the key words. AE, DBG, and CF are parallel. So these 3 lines here drawn are parallel. Think about some of the key words. Parallel should link to things like Z angles, F angles. Some of you may know them as corresponding or alternate angles. DA equals DB equals DC. So some of these lines on the diagram are equal to each other. They're also shown by these little dashes, which give rise to the type of triangles that are given in the problem. So if 2 sides are the same, we know it's an isosceles triangle, which is going to be useful. And then angle EAB and BCF is 38 degrees. So make sure any information is on the diagram as well. It's always good exam technique. Work out the size of the angle marked X. So sometimes we see students rush to work that out in one step. Often is not the case when there's more than 1 mark available for the question. So we may need to work out other angles before we get to the angle X. So with a problem like this, that was meant to be a straight line, sorry. Because the question mentioned parallel, what I'm looking for are particular angles, Z angles or F angles more so. So I'm just going to do that again. You can see this here is a Z angle, and angles within the Z are equal. So if this angle here is 38, then the one I've marked at the bottom must also be 38 degrees. Since this triangle, as we mentioned earlier, is an isosceles triangle, the base angles of an isosceles triangle are also the same. So we can write that as 38 degrees as well. So if we just get down the working that we've got so far, we can say A, B, D equals 38 degrees. I'm just going to write alternate angles, which is the correct name for Z angles. So ABD is 38 degrees. Whenever we talk about angles, it's that middle letter where the angle is actually, the angle that we're talking about is the angle at B. The next bit which we've established there is DAB is 38 degrees as well. And that's because it's an isosceles triangle. I love spelling this. And I love seeing how students spell it as well. It's always very interesting to see. So yeah, an isosceles triangle, base angles in an isosceles triangle are the same. It's very important you write base angles are the same. Lastly, we can now work this angle out here. With this angle here, because we know angles in a triangle add up to 180, to work out that angle, we can do 180 minus 38 add 38. Basically 180 minus the sum of the other two angles. Now you can, obviously this is a non-calculator paper, so you'd do this without a calculator, and I'd encourage you to take time when you do these sorts of calculations just to make sure you don't miss out any marks. So 180 minus 2 lots of 38 is 104 degrees. So this angle here is 104. Now you'll notice the triangle at the bottom is identical to the triangle at the top. In case you're unsure why, well, there's another Z, and I'll just change the color on this. There's another Z angle that exists here, and it includes that same angle of 38 degrees. So that would be 38, this would also be 38, and this angle here would be 104. So the final mark from this question would be to actually work out the x. And to work out the x, we know that the angles around a point add up to 360. So we can do 360 minus the other two angles. So minus 104, add 104. So you're doing 360 minus 208. Again, it's a calculation that I wouldn't rush, and I would encourage you to do it quickly but carefully. It's 152 degrees. So where do your marks come? Well, your marks would come from identifying one of the other alternate angles. That would be 1 mark. One of the marks would come from identifying the 104 degrees, so the idea that angles in a triangle add up to 180, and the last mark would obviously come from getting the correct answer through the calculations that we've done. Right, on to the next one, which is, I believe it's a ratio problem. Ratio is probably one of the least favourites in terms of topics, because it can be asked in so many different ways. And a lot of students enjoy ratio, but when it comes to being examined on ratio, it can be asked in so many different ways that students do sometimes find it quite troublesome. So let's try and break this down as much as we can for you. The ratio of number of men to the number of women is 3 to 2. So men to women are in the ratio 3 to 2. 40% of the men are under the age of 25. 10% of the women are under the age of 25. What percentage of all the people in the company are under the age of 25? So 40% of men are under the age of 25. This question is quite good in the sense of it's not given us a quantity. It's not told us how many men or women there are. It's just told us the ratios in which they are in. So what we can do to make this question actually a lot easier, and to avoid sort of decimals in our calculations because it is non-calculator, is we can change this to 30 to 20. We can do that because if we simplify this ratio, we'd still get 3 to 2. So we've created an equivalent ratio. We've done that to keep the numbers nice. Because our next step here would be to work out 40% of the men, so 40% of 30. So 40% of 30, rather than working out 40% of 3, which would be a decimal. Okay, so the idea behind that is to make the calculation a lot easier. You could have written 300 to 200 if you want. It would not really make a difference to our final answer. It would just make the numbers a little bit bigger to deal with, but that's all. Anyway, 40% of 30, well, 10% is 3, so 40% must be 12. 4 times 3 is 12. 10% of women are under the age of 30, so 10% of 20 is 2. So we've got here 12 out of 30 are under the age of 25, and 2 out of the 20 are under the age of 25. So in total, we've got 14 out of 50 people that are under the age of 25. The question asks us what percentage of all the people are under the age of 25. So what we'd do with this percent, meaning out of 100, is we'd write this fraction as an equivalent fraction, but out of 100. So how we do that is we think, what do you times 50 by to get to 100? You just double it, so you times it by 2. And with maths, whatever you do to the bottom on a fraction, you do to the top as well. So you do 14 times 2 to get 28. So we've created an equivalent fraction. It's out of 100, so we can interpret it nicely as a percentage, 28% there. Okay. Now the marks on this, because there's quite a few different ways of doing this question, they're not as easily identifiable, but you get 1 mark for identifying either 40% of 30 or 10% of 20. You get 2 marks for identifying both of them correctly. You then get a mark for getting somewhere in terms of a fraction that is representative of the people under the age of 25. And then you get 1 mark for obviously getting the correct answer there. Okay, like I said, there are a few different ways of doing this one, so it's not as easily identifiable to say, well, where do all the marks come from? Moving on to the next one. In fact, this is another shape problem, so let's look at something a little bit different. Yeah, this is algebra, so look at a little bit of algebra. This is still non-calculator, and that is the first exam which most students will get when it comes to mock exams. Again, you know, it's nice to know the maths, but also be good with your mental arithmetic and your non-calculator methods. So, the diagram shows a right angle triangle. All the angles are in degrees. Work out the size of the smallest angle of the triangle. Now, it's hard to actually see which of these is going to be the smallest. We'd probably assume it's going to be this one, since it's an acute angle. But there's no numbers, there's more algebra in there than there is anything else. So we need to think, what do we know about this? And how can we form an equation to help us solve the problem? So, since it's a triangle, I know that all the angles in a triangle add up to 180. So what I can do is we can add up all the angles, interpreting that little box as a 90 degrees, and make it equal to 180. So we've got ourselves a little equation that we can now solve, and it will obviously work out what x is. So rearranging this and collecting the like terms, we've got 12x add 108 equals 180. Subtract the 108 from both sides and we get 12x equals 72. And then we can divide both sides by 12. 72 divided by 12 is 6, so x equals 6. Once you know what x is, you can sub that into both of the angles. So you can do 7 times 6 to get 42. And you can sub it into this one, 5 times 6, add 18 to get 48. So the size of the smallest angle in the triangle is obviously going to be this one here, which is 42 degrees. We'll look at a few more problems. We'll try and get some calculator problems in there. So this question here is 3 marks. You would get 1 mark for getting an equation, correct equation. You'd get a mark for a correct value for x, and then you'd get a mark for identifying the correct angle, size of the smallest angle in the triangle, which is 42 degrees. Going on then to the next one. Let's have a look. So we've got a box here with a bit of information, and quite common with the new GCSE is being given formulas. A lot of the formula you do need to learn. Anything that you don't need to learn, I would still say learn, because it will speed you up in the exam. Okay. In particular, like the quadratic formula used to be given back when I did my GCSEs, but the teacher still encouraged us to learn these formulae so that, one, you know how to use them better, and two, you're not wasting time in an exam trying to re-understand what the formula means. So this one luckily has been given, and it's quite a straightforward one, so let's see how we can use it to solve this problem. So a box exerts force of 140 newtons on the table. Pressure on the table is 35 newtons per meter cubed, meter squared. Calculate the area of the box. So we can write out the formula. And we need to rearrange it for A. So if we rearrange that for A, let's see what we get. So you can take the A up and you can bring the P down. Oh, there's two ways of doing this one, so I'll show you those. That's a correct rearrangement, but if you struggle with rearranging, what you can do is you can use what you will probably be more familiar with in science, are the little science triangles. So since we want to work out area, it's just force divided by pressure. So the force here is 140, and the pressure here is 35, which you've got in the question. It's a straightforward division, 140 divided by 35 to give us 4. And 4 would be your answer, obviously. It's area, it's a measure of area, so the units in the question are meters squared. Right, so we're back. On to the next problem then. So a quick zoom in. Something a little bit different. Teachers often avoid this and just let students figure it out in the exam. I know a lot of students that seem to struggle with probability, and ask them why, and they just say, well, we haven't actually done much of it, which is a shame, because I would say it's a nice mark topic where you can bag a lot of marks quite straightforward, because with probability, one of the key things that will carry you through a question is the idea that probability adds up to 1. So let's have a quick read of this problem. There's only red counters, blue, green and yellow in a bag. The table shows probabilities of picking a random red counter and picking a random yellow counter. The probability of picking a blue counter is the same as probability of picking a green counter. So these two probabilities are the same. Since we don't know what the probabilities are, let's just call them X and X. Complete the table. So, as I mentioned first, a lot of the probability questions will rely on you knowing the simple fact that probability adds up to 1. So what we can do is we can come up with a little equation, 0.24, add 0.32, add X, and if you don't like algebra, you could have called them question mark and question mark, okay? And you make it equal to 1, okay? So if you then simplify, so if you do 0.24, add 0.32, you get 0.56, add 2x equals 1. Subtracting 0.56 from the other side, so 1 take away 0.56 gives you 0.44. So 2x is 0.44, so x would therefore be 0.44 divided by 2, which is just 0.22. The idea of these two probabilities being the same could be worked out in other ways as well, but I quite like bringing the idea of algebra into this, because it is only going to help you with the other topics and other questions that we come across, because they do rely on one, having clear methods, and two, algebra is becoming more and more of a thing in the GCSE. There's 2 marks for this, so you get 1 mark. Let's have a quick look. You get 1 mark for showing a process of understanding that probabilities add up to 1. You get the 2nd mark for obviously getting the correct value of 0.22. Okay. Next problem here looks at volume. In fact, it's one of our multi-step 5 markers, and this is what I would say is a beauty in terms of if you've got time at the end of an exam. It's one question you do not want to miss out because it carries big marks. So even if you get some of those marks, that's better than missing out a problem completely. So with a question like this, how could you gain marks? Well, there's so much opportunity because there's 5 marks available. And these questions are not made to make students fail. They're just require you to just think and do things in a stepwise approach. So you've got a cuboid here, and it's meant to be a sand pit. Sally wants to fill the sand pit with sand. 1 bag costs £2.50, and there's 8 litres of sand in each bag. Sally says it will cost less than £70. Show that she's wrong. So one of the things that really makes me laugh when I do mock exams is when students say Sally is right. Please don't do that, because it says Sally is wrong, okay? So you don't want to say the question's wrong. The question's obviously the question, and you want to show how she's she's made a mistake somewhere and where that mistake has happened. So since we're going to fill this box with sand, the first thing you would do is work out the volume. The area inside the box is called the volume of the cuboid, and the volume of a cuboid is just length times width times height. It's the classic opportunity for students to just times the numbers together. Okay, 40 times 60 times 100. This is all non-calculator, so again I would encourage you to use a method where you're doing 4 times 6, which is 24. Times 100, so we've got 2 zeros on the end, and then we've got 0, 0, so another 2 zeros on the end there as well. Nice way of timesing just large numbers that are multiples of 10 is to just times the other numbers first, other digits first, and then we'll put the zeros on the end. Units are going to be key here because the question talks about litres. So the volume of the box is 240,000 centimetres cubed. A good conversion for you is 1 litre is 1,000 centimetres cubed. That's not given. In fact, in some questions it is, but in others it isn't. So I'd encourage it to be something that you take away with you and learn. Anyway, so if we want to convert centimetres cubed to litres, we simply divide by 1,000. So that's 240 litres. Okay, so we can fit 240 litres of sand in this box. Well, the sand comes in packs of 8 litres. So we need to know how many packs we need. So we can do 240 divided by 8, which is 30. Again, I'm doing 24 divided by 3 by 8, which is 3, and then putting a 0 on the end. So that's 30 bags that we need. Each bag is £2.50, so we can do 30 times £2.50 to give me 30 times 2 is 60, and 30 times a half is 15. 60 add 15 is £75. So the total cost of everything Sally wants to fill that box up is £75. She said it was 70, so we can see she's made her mistake there in her calculation. The marks here, let's have a look where the marks would come from. So you've got 1 mark for getting a correct volume, a 2nd mark for a conversion, okay, a 3rd mark for the number of bags, a 4th mark for a correct answer that you can compare to, and then we need that fifth mark. So that fifth mark would come from a comment. Okay, so you just need to write something simple. It's not an English essay. You just need to write. It would cost £75, not £70. Okay, some sort of conclusion, just to show that you've got an understanding and you've been able to interpret your answer there. I think we'll go with one more problem, and have this as a calculator paper problem. So the problems on a calculator paper, I often get asked the question of, so which topics are going to be on the calculator and non-calculator. With maths, it's pretty much anything can be on any paper. There's only a handful of topics that are most likely to appear or would only ever appear on a calculator paper. But more so with the new spec, it is very much anything can come up anywhere. It just depends on the numbers involved. So, be prepared. And I think it's quite nice to revise for maths because you're just revising everything. Best way to revise maths is through practice, and if you're practicing a variety of things, you can't really go too wrong. So we'll make these sort of the last two problems for today. Frank, Mary and Seth share some sweets in the ratio 4, let's just change the colour, 4 to 5 to 7. So Frank, Mary and Seth share the sweets in that ratio. It tells you in the question that there's a Seth gets 18 more sweets than Frank. So students quite often, when they see ratio in this way, they just add up the numbers and then go from there. But it's very important to understand the problem before we do anything. The problem says that Seth has 18 more sweets than Frank. So the way to go about this problem is not the typical ratio way. As I mentioned earlier, it can be asked in so many different ways. Is to see that the difference between Frank and Seth is 3 parts. Okay, he's got 4 parts of the ratio and Seth has 7. So the difference here is 3 parts. That 3 parts represents those 18 additional sweets that Seth has. So since 3 parts represents 18 sweets, 1 part must represent 18 divided by 3, which is 6 sweets. So since 1 part is 6 sweets, we can then work out how many sweets each of them have. So I'm just going to quickly get rid of this. Work out the total number of sweets they've shared. So 1 part is 6 sweets, so 4 parts would be 6 times 4, which is 24. 5 parts would be 6 times 5, which is 30. And then 7 parts would be 6 times 7, which is 42. Now, I wouldn't take any chances on a calculator paper. I would use my calculator. Okay, so I'd do 24, add 30, add 42, which is 96 sweets. You can always do it in your head and then check on the calculator, but it's a calculator, so let's not waste any time there. Where do the marks come from? Well, one of the marks would come from actually getting 6 sweets as representing a single ratio or a single part. The second part would be getting some of these values correct, so 2 of the 3 values, 24, 30 or 42, and the third mark would come from getting the actual correct answer as 96. The last problem here is a triangle, and we're asked to work out what x is. You can see it's a right angle triangle. You're even told it's a right angle triangle. So missing angle in a right angle triangle would mean it's a trigonometry problem. In fact, it's SOHCAHTOA, just to be more specific. So SOHCAHTOA, a good way to start these problems off is to label the sides. So if this is your angle, 5 would be the opposite. And since here's my right angle, the side opposite the right angle is the hypotenuse. So O and H, opposite and hypotenuse, are the letters that are involved, meaning we're going to use sine. So sine theta, sine of the angle, is opposite over hypotenuse. If we sub in everything that we know, so we can say sine x equals 5 over 14. And since we're working out an angle, we'd then need to do the sine inverse using our calculator of 5 over 14. So we're just going to do that quickly. If you're unsure where the inverse is, it's shift and then sine. You can enter in the fraction. Make sure you close the bracket. Sometimes some of these calculators don't pick it up. The correct answer there should have been 20.924. It says to 1 dp, so I'd always write a few numbers after decimal first before rounding correctly to 20.9 degrees. To finish that question off, let's just see where those marks would come from. It's only 2 marks, so there's not going to be much room for error here. In fact, the first mark would come from getting this equation written. Okay, so sine x equals 5 over 14, and the second mark is just the correct answer there, rounded, and that's it. So hopefully that's been useful. In the future, again, please get in touch with Sherpa if you are interested in learning more about any of the problems we've discussed today. And yeah, wish you all the best of luck with the mock exams that are coming up, and I'll see you soon.